Well, hello everyone, and welcome into yet another live stream. And today, we will be, text, but damn it was almost a perfect beginning. But I had the textbook open, I had the notebook open, I had the music open, I was ready, and then I just... Well, what a shame. Anyway, I just realized how slow our progress is when it comes to this alchemy textbook. Yes, precisely, alchemy. It's really slow, but at the same time, it is a really dense textbook, and dense is definitely a good thing, at least in my personal opinion, and it's an amazing one. Did I already mention how much I love this textbook? As always, the first link in the description, literally at the top, is a link to this very textbook, in case you like to learn some alchemy for yourself. And it's definitely alchemy, not material science. That would be silly. Anyhow, we're still in the first chapter, second sub-chapter. Oh wow, okay, so oh yeah, wait, hold on, no, we already went over this. We have also went over these. So now we're going to energy, heat, and temperature. Taking stuff slow is the best way to learn. It depends. It really often depends. Alright, what is energy? Energy is one of the most fundamental universal physical... Yeah, we're getting right into it, because we're not getting a lot of progress done. Remarkably difficult to define in a way that's meaningful to most people. Yeah. I have the fact that energy is not a thing that exists by itself, but rather an attribute of matter. And also of electromagnetic radiation that can manifest itself in various ways. This stream is so heterogeneous on... Yeah, I mean, for real, mate. So heterogeneous. Hi, the soda, by the way. I mean, for macroeconomics, you need to speedrun. Yeah, for macroeconomics, I can't. Hi, the Ali. Oh, are we bringing all the mods together again? Oh, that would be fun. Oh, not actually, not mods, crabs. We're bringing crabs together. Damn it, I'm getting distracted again. Yeah, oh, hi, the soda. I didn't know you were in the voice channel. Hi, you want to sneak up on me, play some silly sound effects in the background?
Hi.
I knew it. I'm always watching.
I'm always watching.
Is that you? What? Okay, well, I didn't like that. I'm getting distracted again. Sip of coffee. Oh, I drank it already. Okay, well, pill would be good enough too, I suppose. Who's in voice chat? It's so that KC Music in YouTube. So YouTube https make it YouTube https youtube.com/@sodakc music. Oh, stop advertising me, mate. Your music is literally playing in the background, not a figurative literally, only literally. It's like giving me Joker vibes right now. Oh, can you say one of these classic Joker lines, like, I don't know, throw me to the wolves and might come back a father or something? No, wait, what was the Joker always says?
I'm not saying that.
Why? You coward. You're too afraid, you know, society, that's the why. Wait, do we really only have 3 people watching? That's my other revenue. Hold on, I'm getting distracted again. Damn it, fudge sticks, y'all are... No. I'm still on the first chapter of the textbook, for goodness sake. It has... How many? Come on. It's got 12 well, 11. It's got 11 chapters, and I'm stuck in the first one. We need to stop getting distracted, educated. Precisely! It's me, the joke. Yeah, I love that one. Remember when Batman was fighting Joker, and then Joker said like, it's joking time. Yeah, I cried in theaters, honestly. My favorite VTuber streaming magic. That sounds fun, yeah. Hold on. What is energy? Good question. What is energy? We have kinetic energy, a sort of motion of an object at body with mass m moving at velocity v, positive the kinetic energy of 1/2 mv squared. There is a fun way to derive this formula and I really like it, but the point is, this v squared part is important. If you double your speed, you consume 4 times as much fuel. Glucose for running, gasoline per car. Yeah, okay, makes sense. So, note it down. Let's go. We're speed running right now. We are going through it. Kinetic energy So basically, just suck it. Stop. Okay, there we go. Hi Ninja, hi! I joined just to become distraction. You're not gonna succeed. I'm gonna... because I am mighty, powerful, handsome, funny, and intelligent, and so I will not get distracted by such silly attempts. The squared, sick. Now we have potential energy. Is energy of body by virtual location in the force field, gravitational or electromagnetic. For example, if an object of mass m is raised off the floor to a height h, its potential energy increases by m gravity h, where gravity is proportional constant, and acceleration gravity is potential energy of particle. Okay, so for this we don't have a single equation, which makes sense. Because, well, it depends on where the particle is. Electrical field, gravitational field. I'm awesome. A field of sorts which acts upon, or just anything acts. So potential energy is a bit more complex. Potential energy. What's wrong with me? There we go. 7th time the charm. Here's the thing about learning, Maker. We can't really speedrun learning if you want to retain the info. Yeah? Watch me. Ali, you're just a hater. You'll see. You'll see. I'll prove you wrong. There we go. It's gonna be defense. I'll show ye. Okay, if you can hold above your head, you just increases potential energy and falls speed of gravity and let it drop. Newly acquired potential energy begins to reappear as kinetic energy, accelerates down with a velocity of 9.8 meters per second every second. So the surface, the potential energy you have gained book now and that kinetic energy. Go on then. You don't believe in me, do you? You're gonna look like such an absolute fool. There we go. The more you think about it, the more... Okay, so... still in its effect. Disperse the thermokinetic energy. The molecules book, yes, I know how energy works. Okay. Thermal energy. Energy is conserved. It can neither be created nor destroyed. Yes, but it can and eventually always will disappear from a view into a microscopic world of individual molecular particles. All molecules are in continuous state of motion, therefore possess kinetic energy. But unlike motion of massive bodies, such as a baseball car that is moving along its defined trajectory, the motion of individual atoms or molecules is random and chaotic. Damn it! I can do it. Okay, it's almost kicking in, alright? Forever changing magnitude and direction as they collide with each other, as in the case of gas with the walls, or as in the case of gas with the walls and container. Makes sense. Energy can time. Okay, I have to speed run even faster. My reading skills aren't good enough. I never graduated kindergarten. Movement of electrons are now in and learn about these combinations as how semiconductor devices in particular work. Okay, so okay, makes sense. And we've already been studying quantum mechanics for a while now, so yeah, it all makes sense. Bond energy. Oh, we're finally getting into fun stuff. Jeez, in first chapter, we're already getting into bond energy. H2 plus is energetically stable enough to exist as an wait, hold on, it's plus. Hold on, let me first get through this. This would mean plus. Now, chemistry has to be... it's always confusing. That's a good rule of thumb, you know. Just... if you ever wanna decipher any sort of chemical thing, you can always assume that it's more confusing than it should be. So plus means less electrons, because electrons are negatively charged, which means this is H2, 2 hydrogens, plus, so less electron, one less electron, which means this is 2 hydrogen bound with a single electron, which is, I'm pretty certain, a unique bond. I'm pretty certain this is just hydrogen bond. Let's see. Hydrogen bond? Hydrogen atom? No. Oh, damn it. It's not the hydrogen bond. Okay. H2 plus. Hydrogen. Yeah, but like, as an H2 plus. H2. Oh, no, I'm looking for that. You know what? Doesn't matter. No. We'll see. and thus first definition molecule. It is also extremely reactive, so it does not sit around for very long. It can only be observed with a high voltage electrical charge. It passes through hydrogen gas. The blue glow one sees represents its demise as it picks up an electron and reverts to far more stable hydrogen molecule. H2! I was right! I was correct! I'm a genius! Oh, I am so awesome. I don't even know chemistry. Oh, I am great. Alright, consider for example a possible molecule that is hydrogen molecule ion H2+, in which a single electron simultaneously attracts 2 protons! Oh yes, I really am a genius. Congrats, make it. You just understood the simplest possible molecule. That's great. Okay, these protons have an identical charges repair each other, but this is overcome by the electron-proton attractions right here. Net decreasing potential energy when an electron combines with 2 protons. Slow claps. Oh, you! I can hear those claps. Those are no they aren't sincere. Potential energy decreases version now decreases molecule. Okay. Chemical bonds also possess some kinetic energy that associates the motion of the electron as it spreads itself into the extended space. It occupies what we call a bond. This is a quantum effect that has no classical counterpart. The kinetic energy has only half the magnitude of its potential energy and works against it. The bond energy is the sum of 2 energies. Okay, so hold on. Hold the bond. Okay, so the kinetic energy has only half the magnitude of the potential energy and works against it. Hard to digest, but we'll figure this out. Okay. Molecules, the chemical bonds go molecules store the energy that fuels our bodies. Molecules are vehicles both for storing and transporting energy, and the means of converting it from one form to another. Makes sense. When the formation, breaking, or rearrangement of the chemical bonds within them is accompanied by the uptake or release of energy, most commonly in the form of heat. Chemical energy refers to the potential and kinetic energy associated with chemical bonds in a molecule. Makes sense. Chemical energy. What chapter do we build a bomb? I mean, I guess you could try right now. Well, you know what? I feel like it's not like which chapter we build a bomb. It's with each chapter, it's getting more and more elaborate on the bomb, alright? Consider what happens when the hydrogen and oxygen combine to form water. The reactants H2 and O2 contain more bond energy than H2O, so when they combine, the excess energy is liberated, given off in the form of thermal energy or heat. So that's why burning hydrogen and oxygen works? Yeah, it's a question. By convention, the energy content of a chemical element in their natural state, H2 and O2 in this example, are defined as 0. This makes calculation much easier and gives most compounds negative energies of formation. Okay. Chemical energy manifests. Hold on. So, if atoms have less energy after so if a certain bond has less energy than the previous one, atom wants to achieve the lesser energetic one, right? Because in this case, we have hydrogen and oxygen, both of them have relatively 0 kilojoules, and then a bond which has 572 less kilojoules, which means it's more stable because it requires additional energy to get back to this state. So they always go down. Okay. Ali, you're in a good mood today, and I dig it. Alright. Energy scales are always arbitrary. You might think at first that a book sitting on a table has 0 kinetic energy since it's not moving. In truth, however, the Earth itself is moving. It is spinning on its axis. It's orbiting a sun. The sun itself is moving away from the other stars in the general expansion of the universe. Since these motions are normally no interest to us, we are free to adopt an arbitrary scale in which the velocity of the book is measured with respect to the table on the so-called laboratory coordinate system. The kinetic energy of the book can be considered 0. Okay, so it's always relative to something. Makes sense. Everything is relative. I think the Einstein, Euler, Oppenheimer said that. The famous scientist. Heidelberg scientist. Wow, speaking of. We did the same thing with potential logic. We define the height of the 0. Okay. Makes sense. So we always need something relative. Then we have energy units, which is just force displace object by distance d. Makes sense. So walk. That was very interesting. A shame I don't understand English. Hold on, wait a minute. Alright, so walk is equal to force times distance. Or walk divided by distance equals to force. Well, I just rearrange it, makes sense. Let's execute it. Of energy is a joule. 1 joule is the amount of work done when a force of 1 Newton acts over a distance of 1 meter. Thus, 1 joule is equal to 1 Newton meter. 1 Newton is the amount of force required to accelerate a 1 kilogram mass by 1 meter per second in 1 second. And yeah, it's all ones because we're not special like read-online. British thermal unit, never mind! Oh, I forgot British exist. Oh, they suck so much. I wonder, are we ever gonna go back to quantum mechanics stuff? I don't know, there isn't really anything interesting left in quantum mechanics. Like, we could if you want, but what are we gonna learn about, honestly? Energy measure. Okay, so more from this live. This is such a good channel. Thank you. Oh, I appreciate so much. But no, this is actually already a pretty high amount for streams. Hi there, Azio. Hi, welcome. Alright, so for electrical energy, energy is often measured in kilowatts per hour, which is a silly unit, a really silly unit, which I don't like, because I really don't like this unit, because kilowatts per hour, it's hour, right? Kilowatt hours. That's what it is, right? I don't know why this R is there, honestly. Pretty confusing, but I think it's an hour. Kilowatt hours. I really don't like kilowatt hours because kilowatt hours are just joules, but for some reason people call them kilowatt hours. Kilowatt hours, right? That's just equal to walk. So what times time? Hold on, let me just make sure that I'm... Which is megajoules. Or, well, joules. So basically, this is just another way to note down joules, except you have to like multiply by 1,000 divide by 3,600, which is silly. The best thing in quantum mechanics was the Schrödinger equation. Really? We didn't actually spend that much time on Schrödinger's equation. I mean, it was kind of cool, like potential energy, kinetic energy. The most interesting fact about the Schrödinger equation, in my opinion, was the fact that, you know, it's not really restricted to quantum mechanics. You could actually readapt. It's actually like a pattern of just all mechanics, and I really like that. Oh yeah, right. These can all be converted between each other and are used either for reasons of convenience in calculation or by tradition. Most of the time by tradition, and I really don't like it because multiplying by 1,000 and then dividing by 3,600 is just an annoying step which serves no purpose. Heat and work are both measured in energy units, but they do not constitute energy itself. As we will explain below, they refer to process by which energy is transferred to or from something, a block of metal, a motor, or a cup of water. Okay. When a warmer body is brought into contact with a cooler body, thermal energy flows from the warmer one to the cooler one till the two temperatures are identical. Makes sense. So you mess up the explanation, but I've seen your videos a few times. Do you have a PhD in physics or something? No, I do not. I am uneducated. I am just guessing. No, I'm kidding. I do not have a PhD. I don't have any expertise. But at the same time, I do work with people who have those. So, for example, oh, I don't remember. I think Alex was a master. I don't remember. I don't remember what Alex had, but Alex, who was my expert for the quantum mechanics video, just there to double check all of the BS I write down, had some sort of official. I don't remember what Alex had, but Alex was an expert. Also, soon I'll be releasing a chemistry video where I will work with someone who actually knows a lot about chemistry, and once again is an expert, has diploma. So I don't really have any official background in anything. I'm just a random guy who is bored and researches stuff on stream instead of going out to party or having a coffee or just talking with their friends. What were we talking about? Oh yeah, right. We describe this process by saying that delta difference of energy, joules of heat, has passed from the warmer body to the cooler one. Makes sense. They have a difference of energy and they just breach that difference. Makes sense. It is important, however, to understand that heat is the transfer of energy due to the difference in temperature. We often refer to flow of heat, recalling the 18th century notion that heat was an actual substance called caloric that could flow like a liquid. That's a cool fact. I think teachers are worse than you, not gonna lie. Depends. Some of them are really good. Some of them are really good. I just have access, I just make 3D animations, so I have this upper hand, if you will. That's really cool. I really love the fact that whenever we discover a new phenomena, we always think that there is like a substance for it. Like we had caloric, right, for heat. We had gravitons for gravity, or maybe still do. I don't know if they are a part of the current model. We had, I think, ether was for waves, if I'm not mistaken. Like whenever we discover something new, we always give it like a substance. I actually like it. I'm talking about the live streams make it. Oh, well then thank you. I'm really glad I'm helping y'all understand. This is a misnomer. Heat is a process and not something that can be contained or stored in the body. It is important that you understand this because the use of term in our ordinary conversion, the heat is terrible today, tends to make us forget the distinction. Okay, yes, so heat is not a thing of the matter, it's a process. Important, we'll remember. So you have the temperature and then you have the heat. Two different things. It's got a scientific explanation. This is amazing. I am really glad y'all think that because this will require a lot of scientific explanations and I really hope I won't screw up anything. There are basically three mechanics by which heat can be transferred: conduction, radiation, and convection. The latter process occurs when two different temperatures cause different parts of fluid to have different densities. So we have radiation, conduction, convection? Wait, what's convection? I mean, these are pretty obvious, right? What's convection? As in... The latter process occurs when two different temperatures cause different parts of a fluid to have different densities. But how would that help transmit heat? How would that be different from conduction? Also, isn't the difference between radiation... I'm getting annoyed because radiation can be yes. And then by yourself, even if you think understand the thing, because you don't. I can't get... You know what? No, it's fine. It's convection, yeah. I'm smart, I know that is. Certainly. Work is a transfer of energy by any process other than heat. Okay. Great definition, love it. Let's note it down. Work, not so we can delete this. Not important. I'm sorry if you hear this. It's falling. There's batteries. No, it doesn't matter. The point is, the long story. Transfer of energy, which means that work, as in watts, would be just units of energy transferred. Work, like energy, can take various forms: mechanical, electrical, gravitational, etc. All have in common the fact that they are the product of two factors: an intensity term and a capacity term. For example, the simplest form of mechanical work arises when an object moves a certain distance against opposing force. Electrical work is done when the body having a certain charge moves through a potential difference. That's cool, actually. So you have two different definitions of work. You have work as in watts are equals to volts times amperes, and then you have second work, which is mass times... I haven't been doing classical mechanics in a while. Not human activity physics. Thermodynamics, to be exact. Or maybe not, maybe just physics. That's a much more complex definition than I need. I need the basic one. Force times distance. Yeah, so... Oh yeah, we had the definition right there. Force times distance. Oh, you have a Discord. Incredible. I'm gonna join now. Well, yeah, there we go. Discord. Okay, so... so type of work: mechanical, intensity factor, force, and capacity factor, change in distance. Okay. Then we have gravitational potential, a function of height and mass, and electrical potential difference, quantity of charge. So force, okay, so that's actually, you know what, that's actually pretty cool. That's actually pretty cool, and we can note this down as a table, I think, surprisingly, as a, well, gravitational I'll leave for now, but basically walk, wait, no, hold on, that's wrong. Insert table 3x3. Okay, Discord OBS disconnected. We have the intensity factor, we have the capacity factor, and for the intensity factor we have force and potential difference, and right here we have change in distance and quantity of charge, and this right here is mechanical and electrical. So intensity factor and then capacity factor. So capacity, quantity of charge or change in distance. Makes sense. Does it? So this is like total... So this is like a driving force. This is like the effect. Kind of. Okay. Performance of work involves a transformation of energy. Thus, when a book drops the floor, gravitational work is done. Mass moves through gravitational potential difference, and the potential energy of the book had, before it was dropped is converted into kinetic energy, which ultimately disperses as thermal energy. Makes sense so far. I want to make earbuds, but I don't know where to start with Bluetooth first, or materials or electricity stuff. Earbuds. Oh wow, that's a tough project because... Okay, so as a bit of advice, be careful when doing projects when it comes to size. Because optimizing for size is one of the most difficult things you can imagine. And so when it comes to earbuds, they have to be small. And making things tiny is a much greater challenge than you could ever expect. So, how about speakers first? Bluetooth is easy once you understand standards, but need to understand standards, so. Anyhow, what was it doing? Potential energy, yeah. Mechanical work is the process of force exerted on the body. Distance moved is Newton per meter. 1 joule. Hidden walk. Wait, Newton per meter? Yes. Times. That's walk. Newton per meter is equal to joule. Hold on now. Doesn't make sense. Am I misunderstanding something? Shouldn't this be what? Shouldn't this be a what? Because this would suggest energy is equal to force times distance. And walk is... this would have to be per second. To be a joule. Heat and walk are best of as processes by which energy is exchanged rather than energy itself. That is, heat exists only when it is flowing, walk exists only when it is being done. Makes sense. When two bodies are placed in thermal contact and energy flows from the warmer body to the cooler one, we call the process heat. A transfer of energy to or from a system by any means other than heat is called walk. Okay, so heat is basically thermal walk, right? Okay, makes sense. So we can think of heat and walk as just different ways of accomplishing the same thing, the transfer of energy from one place or object to another. Alright, so we have walk. Heat is just kind of walk for thermal, or rather thermal. So if... oh yeah, transfer value, we already have to note down. Okay. To make sure you understand this, suppose you are given two identical containers of water at 25 degrees Celsius. Into one container you place electrical immersion heater until the water has absorbed 100 joules of heat. The second container still vigorously until 100 joules of work have been performed on it. At the end, both samples of water will have been warmed to the same temperature and will contain the same increased quantity of thermal energy. There is no way you can tell which contains more work or more heat. Yes. Yes, makes sense. Okay. An important limitation on energy conversion. In a gas engine converts the chemical energy available in its fuel into thermal energy. Only a part of this is available to perform work. The remainder is dispersed into the surrounding through the exhaust. This limitation is an essence of second law of thermodynamics, which will get discussed. Thermal energy is a very special way. All other forms of energy are interconvertible. Mechanical energy can be converted to electrical energy, and latter can be completely converted to thermal, as in the water heating example we described above. But although work can be completely converted into thermal energy, complete conversion of thermal energy into work is impossible. That is a really useful to remember fact. Complete conversion of thermal energy. Why is it impossible? Entropy, basically. That's as an oversimplification. It's impossible, but other kinds of energy can be converted completely. Okay, makes sense. A device that partially accomplishes this conversion is also known as a heat engine, a steam engine, a jet engine, and the internal combustion engine in a car are well-known examples. That's why electricity is so much better. Because you can convert electrical energy to mechanical energy completely, but you can't do the same thing for heat. So, just with the physics alone, we can tell that electricity is better than conventional engines. That makes sense. Bomb? Why are you all so hot for bombs? I don't get it. Okay, but like, yeah, you may say that engines are nerd, but like, come on. Mate. You won't make this with a bomb, alright? There is no way you could make this sort of thing with a bomb. So like, I'm just saying. Okay? I'm just saying. There is no way you'll ever make this sort of thing with a bomb. You can make this only with engines. So I would revisit that claim if I were you. No. Oh yeah, right. Temperature in this meeting. Possibilities probably. We all have a general idea of what temperature means, and we commonly associate with heat. Average movement of particles, I think? I don't know. That's what I claim in my video, so I'm really hoping I'm not wrong. Which, as we know above, is a widely misunderstood word. Both relate to what we describe as thermal energy, the randomized kinetic energy associated with various motion of matter at its atomic molecular levels. Yes, I was correct. Okay. Heat, you will recall, is not something that is contained within the body, but rather a process in which thermal energy enters the or leaves the body as a result of temperature difference. So thermal walk, basically. So when you warm up your cup of tea by allowing it to absorb 1000 joules of heat from the stove, you can say that the water has acquired 1000 joules of energy, but not of heat. Instead, it heated up, right? If instead you heat your tea in the microwave oven, the water acquires its other energy by direct absorption of electromagnetic energy. Because this process is not driven by a temperature difference, heat was not involved at all. Okay, so water has acquired 1000 joules of energy, but not of heat. Yes, just disconnected, okay? So instead it was heated by 1000 joules of energy, right? It hasn't acquired heat, but it was heated by. Electrical energy, from what I understand, is the best type of energy. No, it's just that thermal energy sucks. So basically, when it comes to all energies, you have like a conversion rate, right? So you have like a conversion rate. So for example, if you ever were to transform 100 units of chemical energy into kinetic energy, you could get like 80 units out of it, right? And so you basically lost 20%. And the thing that sucks so much about thermal energy is that you will never be able to get all of its energy back. So out of 100 units of thermal energy, you could never get 100 units of kinetic energy. That's impossible. But if you're working with electrical energy, then yes, you could. Theoretically, in theory. That's why thermal sucks. But electrical, chemical, kinetic, they are all cool and neat and hip. Okay. Thermometry. We commonly measure temperature by means of a thermometer, a device that employs some material possessing a property that varies in direct proportion to the temperature. The most common of these properties are the density of a liquid, the thermal expansion of metal, the electrical resistance of material. Makes sense. So the electrical resistance of material would be used for digital ones, and density of a liquid, that would be this one. And I guess mechanical would be thermal expansion of metal. Oh yeah, so that type of energy is 100% every time. Not every time, but could be 100% if you're doing it correctly. If you're doing it incorrectly, then you're gonna lose some of that energy as heat. Or rather thermal energy, because you're gonna heat up other things. You're not gonna lose them as heat, you're gonna heat up other things and you're gonna get thermal energy. I think I get it, okay. Disconnecting. Why are you disconnecting? Temperature is the measure of an average kinetic energy of all molecules within the water. I am so glad I was correct in that video. Okay. Because... Can you share docs for the exam? I mean, you mean this one? These are like 2 pages. Not even. This is like a page and a bit. I would recommend this textbook more, because this is actually finished. Quantum mechanics one. I don't have a quantum mechanics document. I mean, I do, but you're not gonna get much out of it. Hold on. The quantum mechanics document is... You're really not gonna get much out of the quantum mechanics document, mate. It looks like this. It's just a random equations everywhere. Stuff like these. Like, this only makes sense if you watch the live stream. And if you watch the live stream, then you don't really need the document. And this is my only one. You have massless, massive, massful, which honestly, I just love. Does perfectly mean by using some sort of exotic conductor? Kind of. Well, you wouldn't need an exotic one, I think. I don't think you need an exotic one. I think it's completely doable using Go standard thing is engineered correctly. That's exactly what I need. You need random equations. Yeah, but these equations won't help you. Hold on. Oh, come on. Okay, well, this... Hold on, I've gotten myself into quite a bit of a predicament. Give me a second. Happy, I am quite skeptical. No, you don't have to... I don't really get how it would help you. There we go. Fuck. Like, for example, this. How could this help you? How's operation? I'm trying to write theoretical research paper on new variant of aerogels and extreme heat management. That sounds amazing. That's great. Hi, the organs too. Hi. That's really neat operation. That's an honest. Come on, Ali. Bring in some enthusiasm to the mix. Indeed. Come on. And now I'm gonna feel silly. Because, like, you're writing a research paper like this, and I'm just here learning about what temperature is. To be fair, we are on the second sub-chapter. Oh my goodness, we haven't even gotten the third one. Why? Oh, this is so long. I guess we're getting through the basics, so I guess that's good. You know what? Strong foundation, important. Even if we know the basics, still important to go through it again. We have nothing. This is the second live stream too. I should really... I'm very terrible. Oh, mate, you clearly haven't seen me in action then. No, you have no idea what terrible means. This is the second live stream, and that's all I've got. And this is all basics. It's walk. Oh my goodness, we only got into walk. I've read some articles about the heat-resistant properties of aerogels, drop your research paper in the Discord when you're done. That's true. You know what? I'm with Ali on this one. Okay. Speaking of temperature, would love peer reviews. I could do one on stream. I already have done it in the past. I am so glad that my audience is smart, honestly. Really often people mention how I should do, you know, lower quality stuff and more clickbaity. But you know, it's always connecting when I'm in the middle of something. Like, my videos get less views, but those views are from people who are smarter, and I really like that. Smart is relative. Well, I mean, yeah, but you know, if you compare it to like the average, which, let me cook in Brawl Stars. Hold on, where are we? Oh yeah, temperature. Measure average kinetic energy. Yes, you can feel temperatures and expression intensity, which, yeah. Temperature scales, temperature comparison conversions. Okay, so this is really basics. Absolute temperature scale, Kelvin. Right. Absolute temperature scale based on Fahrenheit degree, absolute 0. Why would you? Just let Fahrenheit die. Let all of the freedom units die. Make it please use dark mode, but that dark mode is glitchy. I mean, I can if you want, but it's really glitchy. Hold on, how do you even turn on dark mode? Reader mode. Dark mode is really glitchy. I forgot the equation. Yeah, but these equations are like... You need context for equations. Wait, exit reader mode? No. Hold on, how do you enable that? I did it last stream. I enabled dark mode. It works for me on library texts? There we go, dark mode. Let me also check how to enable Google Docs. Google Docs dark mode. Is it an experimental feature? Why? Hold on. Oh, that's on Chrome. No, I need on Firefox. Alexa, Edge, Android phone. How do you on Firefox? There, dark mode. You can also increase text. Oh, they all have. Oh, great. Dark reader version makes websites switch to dark mode. I guess it's convenient, but dark mode on Firefox. Oh, there's an add-on. Fine, I'm gonna download an add-on just for you, no. You're welcome. You are welcome, and make sure you trust it before installing. Oh yeah, it has no ratings. That's great. Head stack, why? Like, why would you join in? Hold on, my extension. Okay, I don't think it's working. Sick. Different reactions. Dark Reader, that's just the recommended extension. All right, Dark Reader. Fine, I will add to Firefox Dark Reader. There we go. Oh my goodness, that is so much better. Wow, wait, I can even disable it. Wow, okay, you know what? That is so much better. Oh, you can't see the dogs even. There we go. Wow, that's so much better. The add-on is recommended in Firefox. Yeah, I just noticed. Wow, this is incredible. I mean, it kind of screwed up my YouTube completely. Like, my YouTube was already in dark mode, and now it's just certain features are darker than they should be. But you know what? We'll cross that bridge when we get to it. Whoa, this is so much better. I feel like a hacker now. Temperature comparisons, absolute temperature scales. It's just Kelvin. Perhaps the most common example. The ideal gas equation state. One form of calculation is to use Celsius with an absolute Kelvin degrees. I need it. There are a few cases you will make a mistake by using Kelvin degrees. Hold on, what now? Blocking every single ad blocker known to man. They're not blocking every single ad blocker known to man. Not even close. If you can't find a good ad blocker, that means you're not trying hard enough. I mean, what? No! Ad blocker is yucky, awful. Don't. Why would you ad block? It's no. Why? It's so awful. No. The importance of absolute temperature scale is that absolute temperatures can be entered directly in all fundamental formulas of physics and chemistry in which temperature is variable. Perhaps the most common example known to a beginning student is the ideal gas equation state. One common calculation mistake is to use Celsius when the absolute Kelvin degrees are needed. Makes sense. Heat capacity. As a body loses or gains heat, its temperature changes in direct proportion to the amount of thermal energy Q transferred. The proportional constant... I'll need to get used to this. So we have... Hold on. We have heat. Hold on. Proportionality constancy is also known as heat capacity. Okay, so makes sense. So we have basically Q is equal to C delta T. Oh, look at me. Like, I'm such a hacker. I know the shortcut to move it into the center. Where Q is... No, lowercase. Q. Q is the amount of thermal energy transferred, then delta T is the difference in temp. I'm guessing. And then, okay, did my YouTube chat just broke or is no one chatting? Because it breaks every now and then. Okay, no, it's fine, okay. Why is there a ham and cheese sandwich in my microplastics? It's like you need, I mean, you need intervention at this point. Proportionality concept. Proportional... or just heat capacity, actually. That would be a better one. Heat capacity, there we go. If delta T is expressed in kelvins, degrees, and Q in joules, the units of C are joules per Kelvin. In other words, the heat capacity tells us how many joules of energy it takes to change the temperature of a body by 1 degree Celsius or 1 degree Kelvin. The greater the value of Celsius, the smaller will be the effect of a given energy change on a temperature. Yes, how do I gain intelligence points faster whenever I get a new personality? I lose them all. Just don't get any new personalities. Just stick with one. Oh, Ali forgot about null. Ali is so mean. 1 degree Celsius is known as specific heat capacity, by the way. Wait, that's 1 degree Celsius, right? Specific heat capacity for unit mass. I have no idea what that means. We'll get there soon. Okay, so makes sense. Heat capacity just tells us how much energy you need in order to change the temperature. Heat capacity. How much energy you need to change the temperature. Why am I mean? On Discord, you forgot about null. Wait, it's boring to only have one. Who am I gonna chat with? What do you mean it's boring? I only have one. Were you calling me boring? You calling me boring, Happy? Is that what you're doing right now? Unbelievable. You come into my stream, chat in my chat, and call me boy. Manly boys. Alright. It should be clear that C is an extensive property. Now, I remember those from the previous live stream, I remember. That is, it depends on the quantity of matter. Everyone knows that a much larger amount of energy is required to bring a 10 degrees Celsius change in temperature of 1 liter of water compared to 10 milliliters. I spoke 7 commas in the sentence. Not the basic chat much. Yeah, you're not chatting with those peasants, am I right, Ali? You're in the higher chats. Artificial hierarchies. I guess all of them are. It was boring that I'm alone. I'm not on Discord stream, I'm just alone. So am I. It's not boring. It's peaceful. You need that balance of chaos and order. And the most extreme kind of order is when you are alone. So you just have to think of it as balance. You can join into the Discord, talk with others, and introduce that chaos into your life, or just sit there alone and become the order, depending on what you feel like, what you need. Something tells me that defense mechanism is in place for other personalities to exist. I'm awful at reading, which is great for a streamer. Yes. I mean, you know, personality disorder, that's kind of multiple personalities disorder, that's kind of why it exists, right? It's like a defense mechanism. Wait, you have Discord? Yes, I do! What? Do really all of you? Come on! It's like the 70th time it's happened! I mention it in every single video! Practically every single one. The For What It's Worth series, I don't introduce ads into those because they are different, but in every single video I mention it! And all of you just skip over my ad segments. Oh, it's making you have a disc. Ali, stop. You are unbelievable. Why do you always skip over the ad segments? So that I am going to defenestrate myself. Or you, I don't know. You know what? I'm not picky. Why did Probot just send rank.png? Can obviously because it contains errors. My Discord bot just died. Why did it send it? You know what? We could analyze PNG, but we're not going to because we have better things to do. Like for example, temperature. Okay. It is also an extensive property. Hi, the other side. Well, today we are doing chemistry, actually. Well, technically, I suppose. No, it is chemistry. We're doing chemistry, material science to be exact. So, we have solution. No, that's example. Different capacities, one having a small heat capacity, one is good great change. Temperature, yes. Okay, so right here we have joules per what now? Okay, this is just the capital C, so heat capacity. The molar heat capacities of moles. Oh, I forgot. Oh, you all know how much I love moles. This totally real unit, which isn't just a freaking constant masquerading as a base SI unit because they wanted 7 for some reason. This is the basic law of Dulong and Petit, which serves as an important tool for estimating the atomic weights of some elements. Okay. So molar heat capacity of... So, heat capacity times mole, because we can't just have... Make is gonna get angry. No, I'm not! No, I'm not! I'm fine! I'm not angry. I understand. Yeah, it's molar heat capacity. You know what? Give me a second. I bought some chocolate for myself. Recently, I was some chocks. I bought some chocolate. Just for this occasion. Just in case I get pissed. I'm not pissed. I'm fine. Okay. We're having fun, right? We're having fun. What do you mean? I'm not losing my mind. No. I'm fine. We're fun. We're having fun, right? We're friends here. We're having fun. So what if it includes moles? Moles are totally... Well, they're not the unit, they're a constant, but it's fine, right? Moles, I love moles. Yeah, it's fine. The intermolecular hydrogen bonding in water and alcohols results in enormously high heat capacities for these liquids. The same is true for ice compared to other solids. Okay. So they have high heat capacities. The values for graphite and diamonds are consistent with the principles that solids are more ordered tend to have larger heat capacities. Cool. As a case, well, I'm gonna actually I could get like I could make like an add-on which would just remove the word mole from everything, but it's fine. There, which went through another chapter, measure of matter. Oh no, stop. There's no such thing. Wait, why is it not linking? There we go. You just had to click on it 7 times. Okay, if this really will be measure of matter, then there is no such thing as a unit of substance. Okay. We're fine. Hold on. Liter, ton. mass. So this is basically mass, distance cubed. Temperature. I don't see any substance. Okay. And research requires thickness and distance. Okay, so this is units. But fortunately... It's okay, it's fine. It's not real. It's not real. It's fine, it's fine. It's fine, it's fine, it's fine, it's fine. Okay, we don't have to learn this because we already know this. Unless we're American, but come on. Why do you study random books, by the way? I'm bored, honestly. That's why. So, basically, for my videos, I do a lot of different stuff. And so I need to know a lot of different things. And so, that's why I study those things. A lot of different ones, precise. Hold on. Dimensional analysis is an important tool. Consider the example using volume. Okay, yes, this is basic stuff. Ranges of mass and weight in chemistry. Important thing, weight is a force. Important to remember. Weight is not a medicine video when... Oh, Ali, I have a problem with medicine. A really big one. And that's that... Well, it's like a double... It's like a double cause of a problem. First part is that it's really difficult to make models for medicine, like 3D models for medicine and graphics. And second of all, which I guess is also caused by the first thing, is that they are really expensive. So in order for me to make them, it would take a lot of time. In order for me to buy them, it would take a lot of money. And so that makes medicine videos really difficult to make. Models are so fun to make. Not medicine. No, not for medicine. For medicine, they are annoying. Really annoying and really difficult. I've tried so many times. Didn't we already have one? Yes, we did. Medicine, you know, Demis one. Which is not subcutaneous, which, you know... I remember how we all love hypodermis? Subcutaneous is just, you know, something that the government wants you to think is real. It's not. Alright. Range of distances. This is such a great stream. I know I'm amazing and awesome and handsome. Alright. Why are we learning about those ranges? I mean, I get that it's like a practical way to visualize the thing we learned in the previous chapter, but I guess these ranges could be useful, but not, well, we will know the range. What do you mean expensive? Are you actually trying to synthesize them or something? Wait, what do you mean? Wait, what? No, I meant models, like 3D models, not... Wait, what? Just plagiarize them. You can't plagiarize models! I wish I could, but I can't. If I could, I would. Unfortunately, that's not how it works. I wish. Wait, what is this? This is meaning of measure. Uncertainty is certain. This is just like third grade physics. We're learning how to like. You know what? Fine, whatever. Let's learn about uncertainty. Accuracy, precision. Oh yeah, I was about to say that this will be the example. It's always the same example. When it comes to accuracy versus precision, let me show you. It's always the same example. Every single time. Every single time it's always the same example. And I love it. All of them are the same one. Which is great. But yeah, accuracy, precision, the uncertainty. Okay, finally something more advanced. Going up. Bye, Aurelian. See ya. I think I would say models. Might have. Meant to call alchemy and following. I'm trying to understand what he is saying. Well, this isn't alchemy. This is not really chemistry. I get that alchemy is like a bit for chemistry, but this isn't really. This isn't really chemistry. It's more like. It's more physics. I suppose. Okay. Pretty sad because they're switching to musical politics. I'll have your eyes examined. This is a great. I love this book so much. Alright. More than one answer in replicate measurements. If you wish to measure your height in your centimeter or inch, or your volume of the liquid cooking, you probably do so without having to worry about error. The error will still be present, but its magnitude will be a small fraction of the value will not be detected. Thus, random error is not something we worry about too much in our daily lives. If we are making a scientific observation, however, we need to be more careful, particularly if we're trying to exploit the full sensitivity of our measuring instruments in order to achieve a result that is as reliable as possible. If we are measuring a directly observable quantity, such as weight or volume of an object, then a single measurement, carefully done and reported to a precision that is consistent with that of a measuring instrument, will usually be sufficient. This is still all basics. This is still all basics. Many variety of ways to express the average. Hold on. Friendship is magic. Physics is witchcraft. That's a banger quote. Oh, I might use it in one of my videos. That's a banger quote. Alright. You know what is a banger? Music by SodaKC Music at youtube.com/@SodaKC Music. YouTube music SodaKC in the background. What did you send? Oh no. Can I play it on stream? Wait, hold on. Can I play this on stream? Or we should remain a secret? Okay, as in, okay, acknowledge my previous thing, or okay, as in I can play it, because I need to clarify for legal reasons. Yeah, that's not really clarification though, is it? Vague. I need verbal. I prefer small streamers. It's more nice than you're there hearing a person talk to chat, not being chaotic. Yes, you may. Okay, there we go. Everyone, this is music by Soda. The makings of a madman. I'm just gonna sit back and drink some. I can't do this shit sober. Holy shit! SodaKC, everyone! Oh my goodness, that was amazing. Oh, I mean, of course, I'm a sucker for obviously, but also I'm a sucker for anything time related. Damn, that's good. So good, right? See why Soda has a crab rank? Damn, that's good. Damn, that's good. Damn, I'm glad that Soda. That's great. So that I'm glad you're here. I should repay you though. Sounds like an action hero music. That sounds like a boss fight music. I'm gonna spend 12 hours on it. You don't have to overwork yourself. Please don't, in fact. Please don't. Just wait till I reach like, I don't know, 1,000,000 subscribers. Because right now, I'm not even... Fine. Yeah. Wait till I reach 1,000,000 subscribers, then I'm, you know, I'll buy you a car or something. Well, there was bring something to bring in the views. I predict 1 year. Really? I don't think so. I don't want a car. Well, my what? I want money. That is fair. Yeah, but money isn't as clickbaity as a car. I'll only ever take cash. Fine. Cash it will be. I'm really having trouble. Honestly, the biggest issue for me is finding a way to pay you. Do you all know just how difficult it is to find an anonymous way to pay? Like, I had an account on PayPal, which got blocked. You want that? I would download the account. Oh, no way, I wouldn't. That's irresponsible. I got a PayPal account, which I made precisely to pay people anonymously, and then it just got blocked. Fortunately, it had no money on it because I'm smart. I'm a smart boy. I could make another one, I guess. It's not that difficult to make a PayPal account. So I guess I could... It's still pretty shady, though. Making like a one-off account, that's easily illegal. I need to find an anonymous way to pay. Because it's actually becoming just a big issue. How'd you get blocked? Well, I didn't verify myself because I... Are you a scientist? You could say that, I suppose, without... Well, define a scientist. How would you define a scientist? Depending on the definition. Not an official one. Anyhow, oh yeah, mean, median, range of series of observations. I mean, we know what mean and median mean, but you know, still kind of useful to go over it. Procedures to report the mean or average value. This mean is defined mathematically as the sum of values divided by the number of measurements. Yeah. Not familiar with this notation, don't let it scare you. I am so in love with this textbook. Because this is what I say every single time I introduce a sum into one of my videos. It's basically like, don't be not afraid. This is just a capital sigma. It's really nothing scary. But yeah, we know what it is, and so points, absolute and relative uncertainty. If you weigh out 74.1 milligrams of a solid sample in an laboratory balance that is accurate to within 1/10 of a milligram, then the actual weight of the sample is likely to fall somewhere in the range of 74.0 to 74.2 milligrams. The absolute uncertainty is in the weight you observe is 0.2 milligrams or plus or minus 0.1 milligrams. If you use the same balance to weigh out 3.2914 grams or 3,291.4 milligrams of another sample, the actual weight is between 3.2913 grams and 3.2915 grams. So with Tefta make it a team, basically. Teftas make it so that... You don't understand how crabs work, me. Crabs are people I shrimp for, and that's all the explanation anyone would ever need. And into that group we have Soda, Tefta, and Ali, in the chronological order. Crabs, precisely. Hi, the call. Hi. Anyhow, yes. So that's the absolute uncertainty is related to the magnitude of the observed value. When increasing the uncertainty of value given certain interpretation, the exponential part should include both value itself and the uncertainty. For example, the proper form would be 3.19 plus or minus 0.02 and then unit. What about Elliot? No, Elliot likes Scorpionism, and because of that, Elliot is an unpaid intern. Elliot knows it. Elliot knows the deal. But until Elliot denounces the evil way of scopinism. Making gives his viewers crabs. It's gross, really. Well, you make it gross. I am respectable. I would never. Remember, kids, HIVs are well. I was unpaid intern for like 10 minutes. That is a true story. That is a true story. But then, you know, the costs were too high. I needed to cut costs, so had to let the unpaid interns go. Propagation of error. We are often called upon to find the value of some quantity whose determination depends on several other measured values, each of which is subject to its own source of error. So basically combining error, right? Yeah, Thompson. Subjects random. Because such errors are random, they cannot occasionally cancel out, but for most trials, we will not be so lucky, hence the scatter in the results. Makes sense. Controversial opinion. Unpaid interns are paid too much. Finally, you said the truth, you know? Oh, fine. Yes, someone who actually understands the issue. You know how hard it is for me financially to support all of these unpaid interns? I mean, they're so picky. Oh, well, all of a sudden they want not starve. Oh, make it, but I need to cover my medical bills. Free. What next? You wanna get paid? Crazy. Suppose you measure mass and volume of a shape, and you are required to calculate its density by dividing one quantity by the other. Both numbers of uncertainties, add the absolute uncertainties. Multiplication, division, convert the absolute uncertainties into relative uncertainties and add these. Or better, add the squares, the square root of the sum, like this I would. Multiplication or division by a pure number. Trivial case, multiply or divide the uncertainty by the pure number. Yeah, okay, so this is actually trivial. This is... They make it. I got some stuff. See a soda? Take a good half luck, good fun. Okay. This example will be useful because it's a it's a bit more of a case, or rather this one. Square root of the sum. Hold on. That the more realistic value of the identity of a sum or difference to other squares. The result is wait, what? Why? Add the squares of each absolute uncertainty, and then take a square root of the sum. Okay, I don't really understand this one, but I'm gonna trust. I want to make it to carve a smile into the mask and go like, why? That is real. Yeah, I was about to say that is real. You know how creepy that would look? Hold on, let me check. I'm curious. You know what? Screw it. Let's check. Let's try it. You know what? This is it. Science slash you might as well. Let's have fun. Let's try. This is gonna be fun. There we go. How would we do it, you may ask? Well, don't worry not. I am intelligent and I know the ways of Blender. Is this the one? This is the one, okay. So we have this material 01, which we're gonna select, which we're gonna unwrap. And then what we're gonna do is we're gonna go to texture paint. And we're gonna have a big ol' smile. You know, just it's like a big ol' new... It's called Untitled, yes. Like it. I'm not good at painting, so... We want it to be as creepy as possible. So basically like this. I feel like different brushes. Hold on. Since it does a face review via blend, that would be yeah, that's what my face looks like actually. This. I just have a big old smile on my face. Preferences. Brush? Oh wow, almost spilled everything. Sick. Neat. Hold on. Okay, I don't think anything broke. Are we still streaming? Or did I end the stream up accidentally? Nah. Are we still streaming? I think we are. You know what? That's... I think is good enough for me. Brush. Dynamic brush menus or input brush set. Wait, import X1, import brush set? I have no idea what that is. What is that? All image files from folder. Do we have any additional brushes? Or because that could be useful. No? Nothing? Really? Am I really gonna do it with a normal standard good old brush? Fine. Alright, now we need to do all of these add like a... There we go. Hold on. I'm cooking, okay? The more dollar-tree it looks, the better. No, hold on. Let me cook here, right? Just trust me. Okay. This is a big ol' smile. That's what I'm gonna call it. And then we're gonna go to shading. And then we're gonna material 1. A bit, wait, no, image, texture, and then a big ol' smile. And then we're gonna take that into displacement, and then we are going to plug it right here. This is going to be... Why is it locked? It should be, you know what, muff. And actually not this kind of muff, only standard kind of muff. And just subtract 1 from 1, subtract this, plug it into scale, height 1, or rather height right here, and then we should get in return is nothing, really. Why? It's not visible. Should it be scale? No, if scale we need to do this. Hold on. Roughness? This is even... I'm sorry, but in Wall Universe... Oh wait, object... No, texture. Coordinate, UV. Please? No, it doesn't work. Why is it not working? Okay, hold on now. That's bizarre. Why is it not working? Texture paint. Can I like... Image... Save... A big ol' smile. There we go. Shading. Open up. A big ol' smile. Why are you not walking? Why are you like this? UV editor. I beg to... Oh, is it the inside? Well, I would explain it. 180. That would explain it and then some. No, it can't be the inside because then it would be visible right now. Wait, what? That doesn't make any sense. Okay, yeah, so that is the inside, which means we only care about the outside. So... But why is this not visible? Non-color. What's wrong? I don't... Good person. I'm like a bad person. People tell me I'm a good person. That's good, yeah? Yeah, people tell you as you're a good person. That sure seems like you would be a good person. Why isn't this working? What's wrong with me? UV? Hold on. What am I doing wrong? That's what I'm doing wrong. Okay, that explains it. There we go. Works. I don't like the pixels though. I don't like the fact that there are pixels. Hold on, maybe this would be a bit of roughness. And then this for the metallic. And this for the color. Maybe not metallic. Or maybe yes, metallic but no roughness. And then what we wanna do is we wanna take the noise texture like this. Right, yeah, okay. Color ramp. There we go. And then just make a little bit white. For like a couple of spots. There we go. Use roughness so that if we have like a light source, like a point, we want it to like this. And then what we basically want is we want and shading. We basically want it to be like a bit more. There we go, and then increase the detail and the roughness. I mean, I guess you could increase it too, or decrease detail a bit, and then increase the amount some more. There we go. This I would love to metallic. There we go, yeah, and then like right here we could then go up. Switch this one to all saturation, the base, yeah, and then increase the value. Yeah, that looks good. Is that something you? Does that look like something you had in mind? Is that what you had in mind? What make it right? I'd say it looks pretty good, right? Yeah, look at how happy make it. Look at the happy little boy. Look how happy into. Look at him. Yeah, look how happy this make it looks. Look at the guy. Look at the happy make it. You know, just smiling. The big old smile on their face. That's a good make it. It would take a while, but hear me out. Go right ahead. It's happy that its bones are wrong. I can't do it creepy enough. Make it Hotline Miami. Make it. Wait, it wasn't Hotline Miami was the shooter game, right? But that I don't know how this style would look like. You know, let me just add something in between. Okay. Or actually, maybe right here. Maybe turn this to like just a really dark one. And actually, we could add some more of this goodness. Like this. decrease the scale. Maybe increase the scale just slightly. There we go. And then right here, want this to be even more distinct, and then the detail go would like to go up, and the roughness also up. That's a good make it. Can you make Fanboy make it? The time was not right for that. Yeah, the world isn't ready for Fanboy make it. That's a decent one though, isn't it? I feel like that's a decent one. Yeah, looks pretty decent. That's a pretty good make it. It's a pretty good make it. Now what we want to do is we want to take is this the material I'm thinking of? No. This is the material I'm thinking of. Yes. Now we want to take this, take a mission. We want to cut the lights actually. And we want to how to do it right. Well, maybe we could do it with a final fixture. Coordinates. There we go. Color ramp. I'm sorry. There we go, okay. That's something. Oh, that's because the UV is supposed to be object, isn't it? There we go, yeah. Okay. Bye, no, see ya, no. See ya, bye. What's the time? I don't know. No, I don't have a clock. Too many people were joking around about my clock, so I had to get rid of it. Why isn't this working at all? Now that's a good question. What happens if we switch to add? Still nothing. Okay, great. That's because I plugged in UV again. Damn it! It's object. It's supposed to be object. Okay. Oh, it doesn't. No, it's not plugged in. There we go. That's something. And now we can just turn this to black, and then we have basically just the strength of 1. This is constant now. I don't really know why. Maybe it's because of this. Haha. So now we want like a line right here. There we go. And right here what we want is a math node that would divide. What's your favorite of all of these? Call, Fibu, or null? There's an invisible comma. That is an awful place to misplace a comma, Ali. Is live ending already? I don't think so. I don't think we're ending yet. Wait, hold on. Why is this backwards? Do I need to multiply or add? It's so hard to tell. Another one right there. I feel like I need to divide some. No, wait, I need to multiply. Map value, map range, yes. Map range 201, and then we need to do it in a way so that it starts at white and then goes through yellow to pink and then is becoming green. Okay. Yeah, this is not working. Oh yeah, because there's no colors. That's probably why. There we go, and there we go. Now that we have this all squared and done, we can just this color ramp, plug it right here, and now we can just place all of these in the appropriate spot. No, let's actually bring them closer together. Like so. There we go. Like this, neat. And now we can bring this right here. Make this red. Switch it to multiply. There we go! Now isn't that a much better make it? And you know what? When it comes to this one actually, we can also take this and we can combine color. We know, mix color right here. Or even better, ooh, even a better way to do it would be to add these two. Okay, we're getting somewhere. You know, I feel like we're getting somewhere. Now, color ramp. No, not this. Like we're getting somewhere. I'm bored. I need more shitposts. Yeah, I'm working on it. Jeez. Yeah, there we go. Now we can just this in, and then this one. Do it with full red to decrease the strength. Be really low. I don't know. We need to mix color. We need to mix color with noise texture. Oh, actually, maybe not mix. Only vector math multiply with this one. There we go. That's a bit better. A little bit. There. That's good. I feel like it's good enough. So yeah, that's what Make It would look like if Make It had a big old smile on their face. And now we know. Now we can just darken this. And there, isn't that this good old looking Make It? You know, a big old smile on her face. You know, just the big old smile. Looking happy as always. It's a happy old Make It. There we go. Another good one. Another good old Make It. Anyway, so that's Make It for you. It's been already 2 hours. Oh my goodness, wait. It's been 2 hours. That's long. That's a long live stream. Ah, that's why I'm so hungry. I feel like I should go. We'll pick this off next slide. Oh. Ali and you know what? I feel like that's it for this live stream. From chemistry to 3D modeling, what a way to go. You know what? It's not that weird for a for a child checkup. Anyhow, I'm gonna go now. I'm gonna go and eat something. Then you know the deal. Walk on videos as I do every day. And I suppose for now will be it. Thank you everyone so much for watching. And have a great day. Bye.